Hello, welcome to this little tutorial about the warp drive. What I like to show you here is how to create an embedding diagram based on the Alcubierre metric and how to put that into Google. So in 1994, Mr. Alcubierre was the first one who actually calculated a warp bubble for a warp drive, and let's see how he did that. So what is the theory behind all these wormholes or warp bubbles? They're all based in Einstein's general relativity. So what are Einstein's field equations all about? Well, they are a set of 16 equations. 10 of them are relevant. But all you have to know at this point here is just that on the right hand side of the equation there is the fuel energy of the spaceship, and then on the left hand side you have the space-time, and in our case that is the warp bubble. Another example would be the Earth. In this case we have the mass of the Earth on the right hand side of the equation, and then this mass of the Earth shapes the space-time around it in a certain way, and that finally leads to gravity. Here we have a little overview for general relativity. So what is this actually used for, and why do we need these equations? Let's start from the left to the right, and we see here in this first example empty space, and that's a vacuum, and as a result we just get flat space. In the next example we have planets, stars and black holes. In this case, as a result, what we get is a funnel shape, and for planet this funnel is more shallow than for stars, it's steeper, and finally for black hole it goes to infinity. And that point in the middle then is also called a singularity. The next example is a wormhole, and a wormhole is another possibility to travel faster than the speed of light. How do we create such a wormhole? What we have to do is put two holes together. So on top we have a black hole, and then on the bottom we have a white hole. So the black hole can suck up all the energy or mass around it, and on the other side then the white hole spits it out. Yeah, the next example is our warp drive, and that is what we like to focus on here today. In this case we have the spaceship which is then surrounded by the warp bubble. And other examples for Einstein's general relativity are, for example, gravitational waves, and they usually exist when two heavy objects in the cosmos are colliding with each other. So like two black holes or two massive neutron stars, when they merge, they usually are supposed to send out these gravitational waves, but researchers haven't found them officially yet, so there's still a lot of research going on. And last but not least, we can also apply general relativity to the entire cosmos, and what we see here is the Big Bang model. So from the left to the right, from the Big Bang, the cosmos space is inflating over time. But you can also imagine other shapes for the cosmos. There's still many research going on, and it's not finally decided what shape this cosmos look like. So it could be also some torus shape or some Möbius strip shape. Let's focus now on the space-time geometry for the bubble. So first what we need is a metric. What is a metric? Metric consists out of 4 dimensions. First is time t, then we have x, y and z for the space coordinates. And then we have a shaping function. Here is a tangent hyperbolicus function where the sigma denotes the thickness of the warp bubble and the capital R stands for the radius of the warp bubble. So if you increase R, the radius, the warp bubble gets bigger. And then if you build the first derivative of this shaping function, and then you get this York time formula, and that is your plot result. And that is your result, the warp bubble. You can also, of course, change the parameters for radius or thickness of the warp bubble and play a little bit around with it. Just a little reminder, why is this concept not reality yet? So the problem what we have here is that we need negative energy density, and till today nobody knows how to produce negative energy. Even though you saw that there are still many problems to solve, you may get inspired, and for the latest you should check out e.g. NASA's Donut spaceship, which looks really interesting to me, and don't forget to check this out.